Hello everyone, thank you for joining. I'm Monty and today I'll be presenting a technical talk on demystifying AWS incident response, a practical perspective. About me, I work at detection and response engineering team at Cred. I was part of a week team at Arista Networks before joining Cred. I do detection engineering, network forensics, and incident response. And I'm a computer science and engineering graduate from Indian Institute of Information Technology. You can find me at topmate.io/Monty. Quick agenda for the day. We'll quickly look at intro to cloud security incidents, followed by the top three services that we have for incident response, basically native AWS services. There are a lot of them, but in the interest of the time and which things are relevant to this webinar, I have put the top three as CloudTrail, VPC Flow Logs, and the GuardDuty. The third section is my most favorite one, where we will look at the actual command lines and all the incident response steps, taking two practical scenarios as an example. One is the IAM credential exposure, and second one is the EC2 cryptojacking. Finally, we will also look at open source project by AWS Labs. That's the AWS Incident Response Framework. So basically, all the things which we will cover in the part three can be automated using this project. Coming to part one, cloud security incidents, incident domains. On a very broader perspective, cloud security incident domains are divided into three categories: the service, the infrastructure, and the application. Incidents in the service domain affect the AWS account, IAM permission, resource, metadata, billing, etc. The one in the infrastructure domain is all the incidents related to your EC2 instances, your VPC, processes running on the EC2 instances, and all the data residing on the EC2 instances. You also have many serverless services provided by the AWS, such as RDS and the Lambda. So any incidents occurring in the application code or software deployed in those services, the incidents pertaining to those areas will fall into the application domain. How do we know that we have a cloud security incident? First, logs and monitors. We have the CloudTrail logs, which provide the event history of all the API calls made to resources within the AWS account. Then we have S3 access logs, which is very similar to the server access log provided by Apache and Nginx. Then we have the VPC flow logs. So what you can do, you can correlate the VPC flow logs and the CloudTrail logs to gain a complete visibility of the endpoint and the network level. Second indicator of cloud security incident is the surge in billing activity. So oftentimes it happens that your EC2 instance get compromised and a crypto mining software is running on top of it to mine the cryptocurrency. So that can lead to a surge in the billing activity and can also serve as a very high fidelity indicator of a cloud security incident. Third is the threat intelligence. So you can always correlate the source IPs in the VPC flow logs, the network logs, with a third party threat feed and can identify the known bad. Oftentimes, AWS outreach, you will get an email communication from AWS support. Say, for example, your programmatic security credentials for one of the IAM entity was accidentally pushed to a public GitHub repository. So in those cases, AWS team will also initiate an email to you suggesting that, hey, one of your credentials are compromised and you need to act on it. Incident response lifecycle, all the steps are almost similar to one in the cloud. The only difference here is the what AWS protects and what the customer need to protect. So if you see the one highlighted in the orange below, AWS team is responsible for the security of the cloud. That is, any incidents occurring in the region availability zone or the edge locations, all the underlying hardware or the AWS global infrastructure that powers the compute, storage, database, and networking, all the underlying software. So if there is an incident in that area, AWS team will be responsible for it. However, a customer is responsible for the security in the cloud, that is all the customer data, the operating systems running on top of EC2 instance. If there is a vulnerability in that, or if your EC2 instance get compromised, so customer is accountable for that. Customer is also accountable for the client side data encryption and the data integrity, and of course server side encryption, all the network traffic protection, you're configuring the security groups, configuring the NACL. So these areas fall into the responsibility of the customer, basically the security in the cloud. Next, we have the top three services which are available for during an incident response, natively provided by the AWS. There are a lot of them, but for the purpose of this webinar, I have only included the top three. First is the CloudTrail, which provide the event history of all the basically API calls made within a resource in your AWS account. Can also be used for governance, compliance, and audit purpose, and you provide and it proves very beneficial during an incident. Key components include the event log that tracks all the API calls. You have the trials. You can configure these cloud trial logs to get delivered to S3 or CloudWatch, and you also get insight events not enabled by default. You need to do it, so that basically detects anomalies or the unusual API calls, unusual API activities, and can identify potential account compromise. Uh, the log content for the cloud trial log, you get the event time, name, resource that the API call affects, of course, the IAM user, the identity of the caller, and the source IP from where the request originated. You can always integrate these cloud trial logs with cloud trial log file validation, which will ensure that your log files are not tampered after they are delivered, say, for example, to S3. You can also do a Lambda automation on top of a specific sensitive API operation. And of course, you can always use the config for resource configuration, tracking, and auditing. You also have VPC Flow Logs that capture detailed information about the IP traffic flowing within your VPC. It's very similar to the NetFlow logs. Log format will have the source destination IP, source destination port. You get the protocol bytes, packets, and action will either be accept or reject depending upon how you configure the security group or the NACL. Data points, as I already told you, get the source destination address, you get action, protocol, packets, and bytes. Similar to CloudTrail, you have various security integrations with it. So what you can do, you can correlate the VPC flow logs with the CloudTrail logs to understand the complete incident. GuardDuty, which is a threat detection service, out of the box threat detection service by AWS, also consume VPC flow logs for threat detection. And as always, you can configure Lambda actions on top of VPC flow logs for automated response. The last one in this section is the GuardDuty, which is the intelligent threat detection and continuous monitoring service. Comes with out-of-the-box rules to monitor your AWS workload. Key components include the detectors that analyzes the AWS resource and network activity. We have GuardDuty findings. Think of it as GuardDuty alerts that gives you detailed insights and recommended remediation actions, which proves very beneficial in case of an incident. The data source for GuardDuty is the VPC flow log, CloudTrail log, and the Route 53 DNS logs. A type of threat detected by GuardDuty, not the exhaustive list, but on a very high level, can detect reconnaissance, privilege escalation, credential compromise, and data exfiltration. Security integrations, you can always have a centralized view of all the alerts using the security hub. And of course, you can configure Lambda on top of GuardDuty findings for automated custom response. The third, we have the practical exercise. In this, we have two scenarios. First is the IAM credential exposure, and second is the EC2 cryptojacking. So let's look at first scenario. So suppose in this scenario, we have assumed that our access key ID and secret keys are accidentally pushed to the public repository like GitHub, and these credentials can provide unauthorized programmatic access to attacker for any resources which are available to to this IAM entity, and so that's an issue which and we will look at steps on how to deal with such incidents. First thing first, how do we detect it? So AWS also continuously monitor and scan the public GitHub repositories and all other public repositories for any committed access key ID and secret access key. So as soon as they find that there is a security credential pushed to a public GitHub repository, they will initiate an email to us. Remember, in the indicators of compromise section, in the section first, we saw AWS outreach, where AWS team reach out to you with an email in with an email communication suggesting that, hey, your one of your resources compromised and can be used for unauthorized purpose. In this case, it will be the security credentials. Parallelly, AWS team will automatically attach a AWS compromise key quarantine V2 policy to the IAM entity associated with the compromise key. That IAM entity can be a user group or role, for example. So if you see the screenshot, you see for all the sensitive actions, the effect is deny. So consequently, the IAM entity associated with this compromise key will not be able to perform any operation on any resource within the AWS account. So even if the IAM credentials are compromised, that credentials won't be able to access anything, any resource within your AWS account. So what do we do next in the incident response step? So we have two options. We can either disable the credential or we can delete the credentials. Disabling is recommended because oftentimes it happens that you have deleted the credentials and it lead to production outrage. So deleted credentials are gone, but if you have disabled it, you can restore it. You can basically, the deleting can be a subsequent step after you have confirmed that the disabled credential do not affect any critical production workload, or if at all it affects, the credentials are rotated with the new credentials, and then these old credentials are deleted. So for the purpose of this demo, let's assume that this is the access key ID which has been compromised, accidentally pushed to a public repository like GitHub. So if we do list access key for a particular user IAM entity called Antisyphon test, for this example, we see that the key is active. So what we can do, we can from the CLI itself, AWS CLI itself, we can use the update access key command, specify the access key ID, and set the status to inactive. When after running this command, we see the credentials are inactive. So this essentially disables the credentials. The other part to this can be before disabling the credentials or before the AWS team attach the quarantine key policy to the IAM entity associated with these leaked credentials. It could be likely possible that attacker use those long-term compromised credentials to generate temporary security credentials using AWS STS tokens. So these temporary credentials function very similar to the long-term credentials, except the fact that they come with an expiration duration. That duration can be anywhere between 15 minutes to 36 hours. So in this example, the attacker has generated a temporary security credential using the original compromised credential and set the duration to 30 minutes. You can see apart from access key ID and secret access key, we get an additional parameter called session token. So what the attacker can do next is configure the AWS CLI, the .aws credential file, and let's say in this hypothetical example, the profile name is attacker. So the configuration is very similar to how you do for long-term security credentials. Only difference is you have added the AWS session token to it. Remember the name of the profile. The profile name is attacker. So now you see that even though the original credentials were invalidated, and those original compromised credentials was not able to access any resource within your AWS environment, still these temporary credentials can be used to access resources. So in this example, I have do a S3 LS, which basically list all the buckets available to this IAM entity. So still the attacker has managed to get a persistence within your environment, even though you have invalidated the original credentials. So how can we fix it? So for the IAM entity associated with these credentials, we need to attach a deny all policy. So that will in turn, prevent this IAM entity to perform any action within for any resources within the AWS account. You can see the policy is deny for every action and for every resource. So that's a customer inline policy that can be attached on top of the IAM entity. So once attached, you can see even though these temporary security credentials give an access denied error. So at last, we can do impact analysis using the CloudTrail logs. So you can examine all the CloudTrail logs for any anomalous activity. Since these keys were committed to the public GitHub repositories, you need to perform a detailed review of all the AWS resources access using this IAM security credentials. And you can also use CloudWatch to monitor unusual spike in API users, billing, or other signs of exploitation. So coming to the scenario 2, we have incident response for EC2 cryptojacking. So what exactly is cryptojacking? So cryptojacking is the unauthorized exploitation of computing resources to mine cryptocurrency. So basically, oftentimes attacker hack the EC2 instances and run crypto miner on top of it. That will lead to a high CPU utilization. And suppose your EC2 instance is part of the auto scaling group, then that can also lead to unexpectedly high billing costs, because if the CPU utilization will increase depending upon the rule configured, the instance will vertically or horizontally scale, and you won't be able to control it unless and until you identify that uh, a crypto miner software is running on top of it. So what are the indicators of compromise for EC2 cryptojacking? Of course, it is sudden spike in CPU uses, unauthorized EC2 instances running the crypto mining process. So you get a dump of all the processes running on the EC2 instance and figure out the anomalous process. CloudTrail and SSH logs also prove beneficial in analyzing for any anomalous access pattern in case of EC2 cryptojacking incidents. So how do we, what are the steps that we do to fix this? So first thing first, initial assessment and containment. So here I'm assuming that the EC2 instance, the affected EC2 instance has already been identified, either using a GuardDuty finding or CloudWatch metrics. So you know the scope, right? And what you do next is attach a restrictive security group to it to isolate this instance from the internet. So you block all the outbound traffic and you block all the inbound traffic, and you only allow access to a forensic VPC or the incident response VPC, so that you can remotely control this machine to kill the processes, take memory snapshot, take text snapshot, etc. So in this example, I have used the modify instance attribute command and have specified the instance ID. So this is the instance ID ending in 3828, which is the compromise EC2 instance in this example scenario. And I have applied a group, security group ending at F6D. So this security group does not allow any outbound or inbound connections. So this security group is already created before, and the profile uses forensics, so that's just a role I have created earlier in my lab, so you can use any profile which has the correct permissions. So you can also do it right from the UIs. So as you can see, the forensic analysis security group is attached to it, the one ending it in F6D, which we invoke via command in the previous step. So the IAM role is important here because in the subsequent next step, so once we have isolated the instance, we need to take the memory snapshot and the disk snapshot, and we also need to remotely kill the processes. So we need to ensure that SSM can remotely control these EC2 instances. So for that, this IAM role, Amazon SSM full access, which is a Amazon managed policy, can be attached to this EC2 instance. The other alternative is you can use the manage instance, SSM manage instance core policy that function in the same way as this policy. So these policies, IAM policy, basically allow the SSM systems manager to control your instance, provided that SSM agent is running on top of the EC2 instance. So if you have deployed Amazon Linux, the SSM agent comes by default. So next step is the EBS snapshot, the elastic block store, that is basically the disk attached to the EC2 instance. So the process is pretty straightforward. As long as you identify the volume ID associated with the EC2 instance. So in this example, I have used the describe instances command and have specified the instance ID, and I am doing a query for reservation instances, block device mapping EBS volume ID. So in the output, I get the volume ID associated with the EC2 instance, and then I can use the create snapshot command and provide the volume ID to it. I can also give it a description saying that I am taking this snapshot for forensic analysis, and you see in the output the state is pending because it will take some time for this snapshot to be created and reflected in the UI. So EBS snapshot is was straightforward. However, for the memory snapshot, AWS does not natively support the direct memory snapshot. So you need to use custom scripts via System Manager to automate this. So in our example scenario, the compromised EC2 instance is the Amazon Linux. So I have used a script called Lime to take memory dump out of it. So what I have done, I have a private bucket called my memory dump bucket. So I have uploaded the Lime script to my private bucket, and then I use the SSM send command feature to basically download this Lime script from the S3 bucket to the compromised EC2 instance and compile it, remotely, install all the dependencies. So after this step, what we have it on the compromised EC2 instance, we have the memory snapshot script ready. In the next step, we can invoke a remote command directly to take the memory snapshot and upload it to the S3 bucket for further analysis. So you can see again, I have used SSM send command. Again, for this command to run, you need to have correct IAM role attached to the EC2 instance, which we saw in the screenshot in the previous step, the SSM manage instance code policy or the SSM full access policy. So in this example, you can see I have invoked the Lime script, and the memory dump is created in the temp folder. So on the left hand side, you can see the screenshot for the from the EC2 connect. So the memory dump is created. And after the memory dump is created, it will be uploaded to the private S3 bucket for further analysis. So again, for the compromised EC2 instance to be able to upload data to S3, that instance should have a correct role attached that allows it to do a put object operation on the S3 bucket. So after this step, you will have the memory dump created. You can use it. You can analyze it by downloading it from the S3 bucket, or can do other automations on top of it. So this SSM send command capability can also be extended to run Velociraptor or other scripts to collect trace data and upload it to S3, or that may can be sent to third party SIM for analysis also. So last step will be the eradication and the remediation. So you need to remove the malicious process, stop or remove any crypto mining process running on the affected instance. So in this example, I'm assuming that crypto miner is the name of the malicious process that is running under the context of EC2 user having a process ID of 31078. So we need to kill it remotely. So again, we can use the SSM send command feature, can specify a comment saying that, hey, I'm stopping the crypto mining process. And in here, I have passed the kill command. So pgrep f crypto miner will basically give you the process ID associated with the crypto miner project process, and that can be feed into the kill command. And of course, the instance ID will be specified. The last section is the automated incident response framework. So all the steps which we saw, the memory snapshot, the disk snapshot, can be automated using this project. So that's an open source project provided by the AWS lab. So you can see cloud formation templates are there. So you basically need to deploy these cloud formation templates that will have step functions on it. And how it work is basically, say you have an instance compromise, all you need to do is edit the tag of that instance and set it to analyze. The listener step function will then attach the correct IAM profile for SSM and S3, as we saw in the previous step, that is needed to control the instance remotely and upload trash data to S3 bucket. It also a feature to send Slack messages, and then it will trigger the memory and disk acquisition, and then at last it will tag the instance with a value of content, and it will attach the a restrictive IAM and security group to fully isolate the instance. So these are some of the references I used while creating this talk. So after the talk, I will share the slide with the team. So if you want to dig deep, you can click on each of the link to understand things in more depth. So thank you. These are my social listed. So you can connect with me on LinkedIn, TopBet, or my portfolio. So thank you all for joining.